So let's talk about one of my favorite problems in the textbook. Now, this one is not one of my favorites because it is funny and weird in its phrasing, but because it teaches a lot of good lessons. And so what I have here is a spool of wire rests on a horizontal surface in a figure, whatever. As the wires pull, so by the way, what is a spool? So I hope you have seen a spool of thread. So it's got an outer, larger radius and then a smaller inner radius around which a string is wrapped. And so that's what we're doing here. And we're just going to be pulling that string at different angles. So we can see as the wires pull, the spool does not slip with the contact point P here, right? And on separate trials, so that's important. Separate trials, we're going to pull in direction 1 there, and 2, 3, 4 separately. And what we want to do is determine the direction which the spool will roll. I will tell you that this problem is very much determine the direction of the acceleration as well as determine the direction of the static frictional force. And that's what we're going to use this as practice for. So notice here, we don't actually have to find what the acceleration is or find anything in terms of a value. We just have to know whether or not this thing rolls left or right. And so we're not going to do it quite in the same order, 1, 2, 3, 4, because I want to talk through a couple of different analyses here, and I find it's a little bit easier to do this in a different order. So 68, here we go, and there's our ground. And so no matter what, we're going to have two forces acting that we definitely know about. We know that Fg is going to act downwards, and Fn is going to act upwards from the point of contact here. Okay, great. So a lot of this is about placement. Now remember, because it's going to roll without slipping, I have two possible placements for my axis of rotation, here and here. We know that there's going to be static friction because point P is not going to slip with respect to the ground, and so either static friction is going to act to the left or to the right. But the thing is, I don't know which direction. So if I don't know what direction acts, I want to create analyses where I don't need to know what that direction is, so that it is independent, which kind of leads us in a lot of ways to thinking about this as the rotational axis. But we'll get there in a second, because there's other ways that we can do this. So we're actually going to start with F3, which acts straight up like this one. So what I want you to imagine is, well, what would happen here in the absence of there being friction? Well, if I pulled up like this, well, actually, let's actually do some axes and declarations first. So up to the right. Now, if this spool rolls to the right, we would expect that to be the direction of the direction that the object would accelerate as well in terms of, or the direction the object would rotate as well. So let's link our declarations. I don't think I actually talked about that yet. Hold on a second. Let's just do a quick, well, what are the conditions of pure rolling? We know V com is equal to omega r and A com is equal to alpha r. So here's the thing. I want both of these to be positive simultaneously. Both of these to be positive simultaneously. Like if the object's moving to the right, I have to think about what direction it would be rotating so that both of these are positive. Because if you don't link the declarations, you have to throw a negative sign in front of these things, and no one ever remembers to do it. So I think that let's just link our declarations and make sure we're not messing that up. Anyway, back to this problem. In the absence of friction, I think you would understand that this object would rotate. If the center of mass was the point about which it was rotating, this thing would rotate counterclockwise. So if you think about point P then, point P should be moving to the right with respect to the ground, which would seem to suggest that Fs would act to the left. And that's sort of the analysis that we're going to do all the time. So we're going to think about what direction would the thing would the point of contact move if there were no friction, and try and see if we can intuit an Fs from there. But let's just verify what's going on there with an analysis that is independent of the direction of Fs. So I'm going to put my pivot there. So if I do a sum of torques about that pivot there, and I'm actually going to call that P because we know that that's point P, or rather than sigma tau COM, this is going to be IP alpha, right? So now here's what we're going to do. What forces are going to cause torques? Well, not Fg, not Fn, not Fs. I don't need to know that. But F3 does not cause. And so does that cause a clockwise or counterclockwise torque? And if we look at that, that would cause a counterclockwise torque. So I get a negative tau P equals IP alpha. And right there, that actually solves the problem because I know that alpha is going to be negative, right? It's got to be negative. I don't care what the value of IP is. And that means that this object is going to begin rotating counterclockwise. And because of the condition of pure rolling, where A com is equal to alpha r, and because we linked our declarations, that means therefore A com is also less than 0, and I've proven what I need to prove, which is that this object would accelerate to the left and begin moving to the left, and that's what the problem's about. Now, let's see if I guessed correctly on the direction of static friction. Well, sigma Fx equals max. The only thing that's providing forces along the x-axis here is negative Fs equals max com. Boom, look at that. A com is less than 0, and I get the same result. I correctly identified the direction of friction from my thought experiment from before. And that's how we're going to do these problems. All we have to identify is the sign of A com, and then we know what the direction it will begin to rotate. Roll, yes. And so that's actually the C part of the problem with F3, but I think it's a good way of starting. So let's start then with F4. I find F4 to be an easier one to do. All right, boom, boom. Okay, so here is F4. Once again, I'm going to put in my gravity and put in my Fn, and we have to guess at Fs. So let's take a guess. Well, first off, if I'm just pulling like this, one logic might say, whoa, hold on.